Hey class, welcome back to the next video about circles and arcs. Last time we talked about naming arcs and how they were named and some of the qualities of a circle. And now we're going to get more into circumference and arc length and all sorts of neat stuff. So let's talk about that. A quick refresher for the last video. Make sure you watch that. We talked about the qualities of a circle. We have a center, we have a radius, we have a diameter, we have a central angle, we have the circumference, and we have bits of the circumference called arcs. And so that's what we talked about in the last video. In this video, we're going to get into a few more notes, and it's about arc measure. Now, the whole thing that I base everything on is relating to 360 degrees around a circle. Okay, so if you have a fixed point and all points equidistant from that fixed point, it's going to go completely around, and the entire way around is 360 degrees, which means that we can have basically arc measures that are related to the angles that make them. So here's how it works. The measure of a minor arc, and you remember what minor arc is, smaller than a semicircle, is equal to the measure of its corresponding central angle. And so if the two radii make a central angle of 50 degrees, then the measure of this arc is 50 degrees. Okay, so that's how this works. So the measure of arc RT is 50 degrees. Okay, so in this case, and so arc measure is really based off of central angle measure. It's not that big of a deal. It's not that big of a challenge, but it can be confusing as long as we know it's all related to 360 degrees around. So why is it important to know it's 360 degrees around? Because what if we were dealing with a major arc? And so if we were dealing with a major arc, and all we knew was the measure of the minor arc, of course we would take that away from 360, and that's what this is all telling you. Okay, it's all telling you that, but just in the basics, we want to talk about that. So an arc measure is very equal to the measure of the corresponding central angle. Okay, so the arc measure is equal to the measure of the corresponding angle, and everything relates to 360 degrees. So now the next thing is the relating this to our old addition postulate. So the addition postulate we've used with segments and angles and areas, it applies to arc measures as well. Okay, so when we're looking at, in this case, the measure of arc ABC, starting from A, ending at C, going through B, is equal to the measure of arc AB and arc BC. Okay, so the addition postulates apply here as well. So let's see if we can apply any of that stuff, or all of that stuff, to the following questions. Remember, everything is relating to the entire way around the circle, 360 degrees. So the first question is asking, what is the measure of the arc BC? Okay, so B from C is here. Now, what do we know about arc BC? It has a central angle of 32 degrees. And as we learned from the notes, hey, if the central angle is 32 degrees, guess what? The arc is 32 degrees. Mr. Katz, can it be that simple? Well, yes, it can. Okay, so but it's of course going to get more complicated, however. So now we know that the measure of BC is 32 degrees. Now the question is, what's the measure of BD? So we have arc BD starting at B and going to D. Now we can assume it's going in this direction. Why can we make that assumption? Because it's a minor arc. Okay, minor arcs do not have the reference point in the middle. It's a minor arc. So it's going from B to D. Now what do we know? We know this is 32 degrees here. We know this is 58 degrees here. So how are we going to figure that out? Simple. Add 32 to 58, and we have our arc measure of 90 degrees. Okay, so the addition postulate works with arc measures as well. All right, so that seems to be working out well. So what about the next question? What is the measure of arc ABC? Now this is a major arc because it has three letters, and so it's going from A to B to C. Wait, that's not a major arc. What is that? From A to B to C, what is that? From A to B to C is a semicircle. And so we could say that with enthusiasm and power. So from A to B to C is a semicircle. Okay, so how do we know that? Well, we have the diameter that's given from A to C. There are other number of ways to figure that out, but we don't need to do that now. But this is a semicircle. So that's not the answer to the question. What is the measure of a semicircle? Well, if the whole circle is 360 degrees. The semicircle is half of that. And half of 360 is 180. There's our good old friend 180 degrees coming back to us. Okay, so that is the measure of arc ABC. Now, if that's the case, well, then we can finally answer this last question. What is the measure of minor arc AB? So from A, starting at A, ending at B, we have a minor arc, and we're going to find the measure. So it's the addition postulate, but backward. We know that, that the whole thing from A to B to C is 180, and we know that from B to C is 32, so to find the missing piece, we just subtract, folks. So all we have to do is take 32 from 180, and we are all set to go. So we subtract 32 from 180, and we end up with 148 degrees. And that is the measure of arc AB. So that is how arc measures work. And I will pause the video here. We'll end this on this note. And we'll come back for a few more challenging things in a bit. So take care.